In this lecture, we are going to learn about system calls in operating system. So what are system calls? System calls are basically, so your operating system manages your hardware, isn't it? So the operating system manages your hardware, it manages input output device, your hard disks, and many other things. Okay, so like CPU, memory, file systems, and so on. Now the thing is, as a user, you want to interact with all these devices to solve your problem. So your operating system has system calls, and that basically manages the hardware and instructs it to do something. So they are APIs, okay, so they are the APIs or functions that help you interact with the directly with the hardware. But these system calls are there so that they keep the hardware protected also, and the users can use these system calls. So application programming interfaces, so mostly accessed by programs. So the higher level programs, the application programs, can interact with the system calls. Okay, so three of the most important is system calls. One is Win32 APIs, another is the POSIX API, and then the Java APIs. So these system calls help you interact with the hardware. Now let's see with some real example what this means. So we will take an example, a very simple example of copying a file from source to destination. Okay, so this is a very simple example which we'll take, but you will see so many system calls are there for this particular copying of file. So you have, let's say, a source.txt file and a destination.txt. Now what I want is that from the source.txt file I want to copy everything into a destination.txt file. So what are the system calls that might happen? So let's see this sequence of code. So acquire input file name. So basically we want to acquire it from the user. So now again you will see that if you write something, so you take an input from the user, that will be from the keyboard. So basically, so I am reading from the keyboard, so there will be a read system call, and then it is from the keyboard, so you have to basically provide one argument which input device you want. So you need to define one file descriptor for the input device. So read is the system call here for this function. Then write prompt to the screen. So again for prompt writing accept input, so this accepting input will take this read. Then what happens, and in fact before that when you write also input the file name, there also you are calling a write system call with the output device as your monitor where you write something. Now what happens, again you do the same thing for the destination.txt. So again we call from the keyboard, we read something, we make a read system call, accept input. Then we try to open the input file. So what we do, open system call will be there where we'll give the file name. Now the thing is, if the file does not exist, this will abort, because you cannot copy something if the file doesn't exist. If the file exists, we open it, and this is a system call, we should remember. So this is a system call. Next what happens, we create the output file. So destination.txt we create. So we will use a create system call that will create your file. Now we will have a loop where we will read from the input file. So now again there will be a read, but this read system call will be reading from the text source text file. So this will be my file descriptor, or the argument basically reading from which file. So it is from some hard disk file. I will read from there, and then what will I do? I will write to the output file destination.txt. So there will be a write system call again, and then finally when I'm done, so I will do close the basically the source file and close the destination file. So a lot of system calls were made, and these are basically read and write system calls, open and close system calls, and so on. So this is the basic idea. And now as a user, so for example if I'm doing a printf in C, that out input source file name, okay, source file name. So this is now your application level printf or C function. But basically what happens, this printf, basically inside there is an implementation of printf. So this will make a system call to, let's say, write. So write to the output device. Okay, so this is there, and then let's try to see. So this is there. So for the system calls, now we will see some examples. So there is a read file function on system call for which is Win32 API. So what it handles, so it has read file, you read a file, and what are the things you need to pass, as we were talking about. So in fact what I had given was a simple one, but it takes a lot of parameters like read file. So it takes, one is the handle file argument, which is the file you want to read. LP void buffer, so there is a buffer where the data will be read into and written from. So when, again, let's try to see one example. So we were taking input from a keyboard. So when you are pressing a key, so basically this buffer is where the data will be read into. So there in the buffer, your data from the keyboard will be read and written from also. Okay, so if you are trying to write something, from buffer it will be taken. D word bytes to read, the number of bytes to be read into the buffer. How many bytes? Let's say how many bytes you want. And LPD word bytes read, the number of bytes read during the last read. So that system call, how many bytes it actually read. And then LP overlapped indicates if overlapped input output is being used. So these things are there, and now this is the system call. System call implementation, basically, so it's kind of table where a number is associated with each of your system call. System call interface maintains a table index according to these numbers. Okay, so lot of system calls are there: read, write, close, open, create file, delete file, and so on. So for all these you have some number. Okay, so and a table is there which have all the indexing. The system call interface invokes intended system call in operating system kernel and returns status of system call and return values. Okay, so system call you make, then basically it is a kernel program. Okay, so OS kernel will run that and then give you the results. The caller needs to know nothing about how the system, so it doesn't need to know how internally it is trying to write to the output device, how many bytes it's reading, and so on. Let's say you are writing a very simple, again, a printf. Okay, so you are writing hello world. Okay, how are you? So how are you? So many lines are there, and let's say one letter is 1 byte. Now printf, when you are calling this, you don't need to know the internals. This in fact will call, let's say, write system call will be there with the same hello world, how are you. Now internally how is this write implemented in the kernel, that you don't need to know as a system caller. So now if only one character or 1 byte can be written at the output device, or 2 bytes can be written, those things you don't need to care about. Or if the input output device is busy, and so on. So that will be taken care by the system call implementation. So you as a caller don't need to think about that. So just need to obey what the OBI parameters are there. Most details of OS interface hidden from the programmer by the API. So you just need to know what are the things you need to provide, how internally hardwares are being used, how are interrupts happening, and so on. You don't need to take care. So this is there. So for example, we will just see system call. User application program is there, it calls open. A system call interface is there. So this is the user mode system call I make. Now inside that, how the kernel is implementing system call open. So open is basically opening some file to be read or written, and it has some implementation which you don't have to take care of as a user. So this is there. So for example, again, it is also showing one example of printf. I make printf greetings. This will make in turn a system call to write system call will put all those greetings on your output device. So system call, now again any function you take, you pass parameters in your system call. So exact type of amount of information vary according to your OS. So again, so how you pass parameters? So like we said that okay, write. So now in write, which output device you want to write to and so on. So these are the things you have to pass as parameters. So simplest thing to pass parameter is that in the CPU you have registers. So you pass these parameters into the registers. But very few registers are there, and if you have lot of data to pass, CPU registers might not help. Then the other thing is to use the memory to pass parameters, okay, or table, a memory, or block, and that's what Linux implements. Okay, so what we do whenever I am calling a function, let's say write with several parameters, parameter 1, parameter 2 and parameter 3, so on till parameter n. So they will be all written on the stack, which is a memory in RAM. So stack parameter, everything will be pushed on the stack. Parameters are placed or pushed onto the stack by the program. And when the function, so when I call the function, every parameter is pushed onto the stack. Your stack is there, everything is pushed here. And when you return from the function, because now they are all local variables, they will be popped out. So block and stack methods do not limit the number of or length of the parameters that are being passed. So this is a better way than use of registers. So this is one example. Then let's see some kind of system calls. So system calls are again, because you are maintaining, you have to interact with different hardwares and so on. So you have different system calls for all of them. So we had taken just a very few like read, write and so on for processes. Applications are running, let's say a lot of applications are running. In Windows you do Control Alt Delete. So what happens, you abort. So there will be a abort system call. Okay, so which you just call with the process number of the application, it might abort it, okay, end the process. Then there is something, I click on one application, okay, in Windows. So basically it will load it in the memory, okay. So this is an application, so it will be loaded in the memory or RAM, and then this is a code for the application and it needs to be executed. So this will be so executed. So these are all system calls. So now it will be loaded into the memory. So the system calls will be load the program P and then execute the program, okay. So these will be done. Then what happens, you also need to create process and terminate processes. And now let's say you have a process, so you want to set it attributes like name, how much maximum memory I can give it to you, its priority and so on. Then if a process is waiting, so wait time you need to define. Then signal events, or process needs to tell some other process, signal it some event. So these APIs also you need to provide. You need to allocate some memory. So alloc system call is there, free memory system call are there. So many are just for your processes. Now let's try to see what are the things that are there for file management. So we discussed about it. Create a file, then you call a create function. System call delete, you will call a delete system call. Open is for opening a file if it was already created. Close a file, so it basically removes it from the memory. Read something from a file, write to it, and some attributes you need to set. Similarly for device, so now you request an input output device, okay. Let's say a printer, you want to request it, release the device. I'm done with the printer printing, so release that device. Read and write, so write something like in printer you give what you need to write. So get device attributes and so on. Information, so again that is also necessary. You want to find what is the time or date, okay. These are there. So which processes are running, applications are running in my computer, what is the how much CPU is being utilized, RAM and so on. Then finally communication, so you communicate among different processes. So send and receive messages are there, shared memory is also there, attached and detached remote devices. So a lot of things we saw about system calls. So basically system calls are the functions that are provided by the kernel which you can call to do different works by the computer. Okay, so whatever hardwares are there in your computer, you can, like process management, then you had information management, communication, device management, file system management, all these you can do using the system calls. Okay, so we will again, so just like here some examples are given. Process in Windows, create process, exit process, wait for single object, and then you have file, create file, read file, write file, close, handle. So you see lot of things are there. So this is about the system calls. I hope you understand this. Thanks a lot.